meeting. And it's a collaborative work. This presentation is collaborative work between UE and the CIMH. And just an introduction, I'm going to start with the introduction, the objectives, methodology, the case study, where it was applied, and some concluding remarks. Just an introduction, how do we see our models in the spatial occurrence? How does it occur? How do we see ourselves, and how do we accept what others show us in the form of maps? And if you look at this if you look at this slide here, we'll see how the building that is shown in red is not quite displayed correctly, right? Is it that it was meant to be shown like that, or is it simply just a human error? The thing about it is, with the digital age, digital software, anybody can make a map. And better softwares now have AI functions, right? Once anyone follows the general rules of making a maps, they can create simple maps. Right, so some basic things just to create maps. The general steps to creating a map, we must consider these steps. However, if we are going to be repeating the maps, then only certain steps need to be considered. And in general, the ones that are shown in green will keep changing if you are repeating the maps. Right? The ones shown in black here are going to remain consistent throughout the map making process. So the objective of this study was analytical solution, prepare data, and make maps for instances of repeated map generation, right? So we're looking at a solution that will prepare the data and publish the maps, one that works on open source, such that it'll be free or low cost, right? One that could reduce subjectivity, thereby increasing the consistency and repeatability of the maps. And in general, one that can save time. Right, so the methodology is whereby data can be processed by some analytical solution that will create graphics. Thereby, the analytical solution will take the graphics, take some templates, use a cut and paste approach, and create a wanted map, the final map that we want. To implement this, we looked at the CIMH map production process for the SPI maps. And these were standardized precipitation index maps that are used to provide early warning systems for droughts. And this was done at different temporal scales. So the general CIMH approach was to take reanalysis data, take climate information, create a localized database, process some of the data in Excel, return the processed information in this database, right? And they are also incorporating their own software, their own C++ routine to extract the SPIs. Once this is done, it was brought into the ArcGIS, the ArcMap function, the ArcMap software, and then the final map was produced. The analytical functions, the analytical solution, was done in two phases. The first phase used the reanalysis data and the localized database in analytical solution here, which was done with R, the R software. And through the R, it called upon their existing SPI routine. Right? And then that information was brought into the ArcMap, and thereafter, the map was created. But in the first instance, in this first phase, the map were improved so that it looks categorically better than what it was before. However, in the second phase, the whole use of ArcMap was eliminated, right? And all of the maps were created automatically inside of R by calling upon an extra function that used the generic mapping tools, right? Because R is command line based, a graphic user interface was also implemented to make it easier for the user to actually correlate bring together all the information and create the maps. How the map process, or the map production process was done, it brought in an ASCII list, which was the information that was created from the first phase. It interpolated those points, right, along with the information that existed in some sort of stored database. And this interpolation was done with the generic mapping tools. And in R, it applied a mask, classified the data sets, applied a color ramp, overlaid the other information, added our text and annotations, and then transferred this information into basically blank templates. So it used the cut and paste approach. And the final results as came out of the R, as you can see, is this cartographic product that looks very similar to what came out of the ArcMap. Right. The results, the processing was found to be far better, with less errors in the analytical solution. Through the analytical solution, we were able to publish much more products, different formats. The data management was much better. The analysis was easier, it was more efficient, and was more accurate. The map production was, again, easier, efficient. It was more reliable, it was more repeatable, and had less subjectivity. Because one of the functions was, again, in integrating the satellite-based information or the reanalysis information with the land-based information, the user would eliminate some points. The software now determined which points to eliminate based on the criteria that were defined. The production time was reduced from 2 days to about 13 minutes. And this is a table summarizing everything. Another aspect of it, the quality assurance, which was done by the operator, is now done by the algorithm. The only difference probably was some aspects that was QC'd before is now done after. Another aspect, though, the number of products was increased from 6 maps to 13 plus maps. And this was made possible because the analytical software could do more analysis on the maps. So at least 3 maps that were created were like ratios and percentages, differences, and so on. Right, so you had some extra maps that were now being processed by the software, and actually these extra maps being created as part of this routine. Right. In conclusion, the analytical solution was found to be effective, right, and it improved the overall processes of the data and the map making system. It was still able to maintain the high quality cartographic standards that was required. And this was done basically because we already had the cartographic rules established in the existing system. Some references, and I'd like to acknowledge the CIMH and USAID for funding this project, and WFO, and of course, thanks very much.
So Dr. Griffith Charles, can you manage this questioning, please?